Functional programming languages. Functional programming and languages are as old as programming. In theory, functional programming languages have the most conceptual contributions than any specific procedural language. In other words, procedural languages became sound and safe by the functional programming actions and reactions. In practice, functional programming languages haven't lived up to the expectations up to this point, but becoming more attractive since 1990s in a big way. Functional programming and languages are not easy to ignore. Functional programming is necessary to know, to understand better the practice of the programming, to develop useful software. In short, elegance in coding can be achieved by knowing and applying functional programming. The question is, how can we learn without much practice? The theory of programming languages is hidden in the concepts of functional programming, which are functions with a return value, information hiding with less parameters and localization. Function is an abstraction of a single simple logic. Function of function is more. Functional programming languages revolve around basic concepts, which are known as state and behavior for programming safety, lazy evaluation for programming performance, types both for safety and performance. Side effect elimination to the extreme gives a useless language. Monads came into action. Purity and laziness in elegance. Type classes, practical and easy. So these are the attractions for programming in functional programming sense. Functional programming languages are used or useful mostly for programming with mathematical functions. In other words, in programming, what versus how and why is the essence of understanding of functional programming languages, such as 5 bang is 120. Why? Because 1 times 2 times 3 times 4 times 5, elegance and simplicity in mathematical notation. Bang or exclamation mark as a symbolic notation for factorial function in math. Names and symbols in programming languages and coding. In procedural programming, in other words, how to based programming, we write in a certain language integer n is 5, integer f is 1, and for integer I from 1 to n, incremented by 1 by 1 to compute f times I and stored repetitively in the final f value, which is the result. Obviously, we can do better coding, especially with recursion. Integer return value of a factorial integer n can be written as if n is equal to 0, return 1, else return n times factorial n minus 1. But in either case, iterative or recursive, we have to devise and design and implement this coding explicitly. Instead, it will be nice to say 5 factorial and get the result as 120. The question is who and how is exclamation mark is coded. In other words, factorial function is coded. Factorial n is defined, then factorial 5 results 120, or factorial 5 without parentheses gives 120. These are all practiced and experimented. The problem is the definition of factorial n, whether it be iterative or recursive. Function programming languages, if the function is well defined and can be callable, then all we say is f is factorial of n is easily understandable. The question and or the problem is how can you safeguard n during the computation? So the problem is not just to compute factorial of n, but while you are computing factorial n, how can you safeguard n value, which is the global value during the hidden function computation will not be affected by the programming language side effects. In procedural languages, over the years, several solutions are introduced and used. In other words, by value by reference issues, as well as type binding, well known and understood. In early days, starting with Lisp and evolving into functional programming and languages, one thing common in functions was and still is to eliminate side effects. How? No state change, no mutable variables or values, and type binding. So, in Haskell-like languages, we achieve this easily and properly.